So now that you've had a little bit of practice with the segment addition postulate, let's look at a more interesting situation. So you might get a situation like this where you have no picture to go along with what you're working on. So you might get a problem that says you have three collinear points, H, J, and K, with J between H and K. And then they might just go ahead and tell you that HK is 17, that HJ, the distance HJ, is 2x plus 4, and the distance JK is 3x minus 7. Now, if you like working with formulas, you can jump straight to the formula. You can say, hey, they're collinear points, everything is set up here, all the conditions are met. I can use the formula for the segment addition postulate, which says that the whole thing, HK, has to be equal to HJ plus JK. And in this case, HK is 17, HJ is 2x plus 4, and JK is 3x minus 7, and then you just do algebra, and you can find x, and you can use x to solve for these. Personally, I wouldn't jump straight to this, because I tend not to work formulaically. I would probably look at this problem and I would say, alright, to make sure I don't make any mistakes, I'm going to draw a little diagram of this. And so first of all, they tell me there's three collinear points, H, J, K, with J between H and K. So I'm going to draw that. I'm going to draw H, J, and K all on the same line, all collinear. And then I'll mark out some of the things I know. So this distance is 17, HJ is 2x plus 4, and JK is 3x minus 7. And I will look at that and think about the fact that I know these two things added together must equal 17. Either way, you end up at the same point, and that is needing to solve this algebra, and that's a good little review of algebra from last year. So first we're going to combine like terms. The 3x and the 2x combine to make 5x, and the negative 7 and the positive 4 combine to make negative 3, and we've got a 17 over here. So next, well, 5 times something minus 3 equals 17, so let's add 3 to both sides. This is 0, and now 20 equals 5 times something. That's a little easier. If I divide by 5, I have 5 x's, and if I divide those by 5, then I just have 1 x, and I'll do the same thing on both sides. 20 divided by 5 is 4, so 4 equals x. Now I take that 4 and I plug it back in here and here to find out what h, j, and jk are. Let's go ahead and do it. 2 times 4 plus 4 equals 8, 12. So the length hj equals 12. So this is 12, and jk is 3 times 4 minus 7. 3 times 4 is 12, minus 7 is 5. Cool. So jk equals 5. So this is 5. And now I can look back here at my diagram where I wrote everything everything in, and I can see that 12 and 5 do indeed make 17, so I'm pretty sure I got it right. On now, you try it. We've got a problem for you very similar to this one, so see if you can apply the same principles using the segment addition postulate and some of the algebra from your last math class.